Hello, and this is the second part of the 2022 additional maths paper. It's video 12 of my sessions. There's 10 on previous topics and session 11 is on the first half of the paper. Okay, we're starting with question 10. It's quite a nice easy start to the second half, just around the staple page. d2y dx squared. You will do a lot of this in A-level maths. First of all, you have to differentiate. And always with these, if you want to stop the video to give yourself a chance to look at the questions before I hit the next click button for the slide. So, first of all, you will differentiate. Giving us the line of 30, however you've been shown to differentiate, multiply by the power decreases by 1, I would say. And remember, it's a calculated paper, so there shouldn't be any problems with doing any of the numbers here. Next thing, you differentiate again. It's called d2y dx squared. And it's useful for helping us come up with the stationary points to know if they're maximums or minimums. But in additional maths, they give you standalone questions like this. It's quite a nice easy 2 marks. So a good start to the second half of the paper. Now your next slide is part B of the same question. Now these I found over the years have proved to be not that difficult, but a little bit tricky, particularly if you make one mistake. So the first thing, you're going to have a y equation and it tells you dy dx. Now the first thing I would do if I was you is differentiate the y equation. Yes, I know that's going to be in terms of a's and x's and b's and x's. And then we'll worry about each of the lines as we get to them. The value of d. So when I first did this question, I probably didn't know exactly what to do until I differentiate the top line. There's quite a few out there that look like this. Some will say d2y dx squared. So let's differentiate the first line. That will give us 3ax squared. Some people might write it down as a 3x squared. Then 2bx, then just cx. If it's a differentiate 7x, you would have written just 7. Remember, the differential of a constant is 0. So I've done that line, d2y dx squared. I've put that one in to help us with the bottom bit. I've differentiated the dy dx first to do d2y dx squared. So I actually this time worked on the bottom line first. So I've differentiated dy dx. That gave me 54x plus 8. And it told me the value of 1 is equal to 1/6 of the coefficient of x. Now the coefficient of x in d2yx squared is 54. Coefficient means the number in front of the x term. The value of d is equal to 1/6 of that. So I actually started the other way around this year. Now my next line is talking about dy dx, which I spoke about at the start of this question. I've lined them up to help me see what's going on. Now you might be able to work out that 27 is worth the exact same as 3a, and that 8 is worth the exact same as 2b, and that c is worth 13. So from that, 3a is worth 27, a is worth 9, and from this bit, 2b is worth 8, b is worth 4, and c is worth 13. Now, all the years I've been doing this, they do give you answer boxes, so you'll be able to see the answer boxes behind me there. Giving you the answers are 9, 4, 13 and 9 on the end. There's quite a lot of questions. If you go through all the past papers by topic that I've created, that you'll see there's a lot of questions like that, where sometimes they do d2y dx squared, sometimes I might put the integral on, anything just a regular type of questions, but they all have their own little twists. Now the next question is coordinate geometry. Now, coordinate geometry is a major topic in A-level, so if you plan on doing A-level, this is really good to get into. They're nice and friendly in additional maths. They lead you into it. It's a perfect forerunner for the A-level part of the course. And there's plenty of e-sgol, Carlum Cymru resources available on this website as well at AS level and A2A level. WJC questions by people who are used to doing WJC exams. So the first one, calculate the length of the line. Now the length of the line is basically, as you've seen in my earlier videos, is basically Pythagoras' theorem. It's the difference between the x values and then the difference between the y values, and use Pythagoras. So let's show you what I did for this one. So first of all, the difference between 12 and minus 3, well, I would have written it as 12 minus minus 3, which becomes a plus, and that is 15 squared. And then the other one says 6 minus 3. So there's separate videos on all of this, and then I've typed that all into my calculator. Now I actually worked that out in my head and then simplified it in the calculator, but if you typed it straight into your calculator, it will simplify it for you. So it's quite a nice easy 3 marks, and I'm sure you'll see that every year on exam questions. It does say in the format n root m. I can't break down 26 anymore. I say the calculator does it all for you. Now the gradient, top bit could be on GCSE maths, unlikely, but Pythagoras theorem is, and that's where it comes from. You square the numbers and then square root them. Find the gradient is on higher tier maths. Find the gradient of a line perpendicular to the line AB. So first of all, we're going to have to work out the gradient of the line AB. Now gradient is change in y over change in x. So I've done here the change in y over the change in x. Or you might know it as y2 minus y1 over x2 minus x1. Just be careful of these minus signs. That gives us 3/15. Now 3/15 is exactly the same as 1/5. Okay, I'm just simplifying that down. Your calculator could do that, but you shouldn't really have any problems with that. That simplifies down to 1/5. But if they're perpendicular, and there's so many different ways people tell you to do this, but two lines are perpendicular, they multiply to -1, their gradients multiply to -1. Alternatively, what you can see is that you change them, you flip the fraction and turn it to the negative sign, or change it to the opposite sign. 1 over 5 becomes 5 over 1, which then you put a minus in front. Because if they're perpendicular, one would be positive gradient and one would be a negative gradient. Now the next question, integration. So the next part is to do with coordinates and midpoint. So midpoint, again, could be on maths. We would have seen things like this in numeracy with mean of group data. Find the middle of 2 points. Add them up and divide by 2. Add them up, divide by 2. Now they gave me 9 over 2. I might have well written 4.5. I might well have written 4.5. They'd accept either of those. Okay, the middle of 2 points, the middle of any two numbers, add them up and divide by 2. Right, then we're on to part B. So say, hopefully you have the question paper in front of you to help you, but otherwise you can stop and look each of those at a time. Find the equation in a straight line with gradient 6 that pass through the point 215. Now it says in the format y equals mx plus c, so again good higher tier math skills here. We know the y value is 15, we know the x value is 2. So then we're going to put in the numbers to work alongside that. Now we don't know what c is worth yet. So first of all, I've written out y equals mx plus c, and then I've replaced y with 15. I've replaced m with 6, because gradient means m, and x is worth 2. Then I've just done 15 equals 12 plus c, c equals 3. But remember, it does say write the equation in the form, so I don't get the 2 marks until I write it out as y equals 2x plus 3. And in additional maths, you need to be in the order they've said, not y minus 3 equals 2x or any other variation. It needs to be written in that order. Next question, integration. Now, when you integrate questions, you can't integrate with x's on the bottom. You need to take them to the top. Now, there are ways of doing them on the bottom, and you might have been shown ways, but the way I would teach it is take it to the top. So that's my first mark. I'm going to say I've taken the 6 over x to the 4 and put it onto the top, onto the numerator, and called it 6x to the minus 4. And I insist all my classes do that. You might be shown a slightly different way, but it's really helpful. Strange with same with differentiation and integration. So simplify your answers as far as possible. There's 6 marks. There's 4 marks for integrating each of them, 1 mark for putting plus c, and 1 mark for simplifying it all up. So first term, increase the power and then divide by the new power is what I say. I for integrate and I for increase. Here's my full answers. So where did I get those full answers from? Increase the power 8, divide by the new power. Increase the power 5, divide by the new power. Okay, the next are a bit trickier. Increase 4. Well, in theory, that says 4 to the power of x, 4x to the power of 0. So you increase it to the power of 1 and divide by 1. You hopefully know that the differential of 4x would go to 4, so the integral is just the reverse. Now, the nasty one, increase the power. Increase minus 4 does go to minus 3, which not everyone always thinks it does. Divide by the new power of minus 3. Don't forget the plus c. Now, at the moment, I've only got 5 marks, so I've not simplified it. What do I mean by simplify? 16 divided by 8, 15 divided by 5, 6 divided by minus 3, and that plus and minus simplified to give me the minus there. That question must have been on, that style of question must have been on every paper I've ever done on additional maths, so look out for that. And talking about styles of questions are always on. Next one. Now this is integration. This type of integration is always easier than integral, but why is it on the paper? Because they're giving you limits. This means the curve anywhere between 2 and 3. This would tell us the area of the curve anywhere between 2 and 3 on the x-axis, in between the curve and the x-axis. So first of all, do straightforward integration, increase the power, divide by the new power. Now I might well have written 3x cubed over 3, but the 3 simplify out. Same this one here would be 2x squared over 2, but the 2 simplify out. And then you put the limits in. Now, for additional maths, you always put, well, for most maths, but you're going to put the top limit in first. I tell my classes this means everything up to 3 except everything up to 2. So I've subbed in 3, and I'm going to show my working. I've not written out 3 cubed, but this counts as showing my working. So I've subbed in 3 first. That gives me 27, and then plus 9. Take away. As I say, it's everything up to 3 except everything. Now I use the word except for minus, but most of you should be told that you just do sub in the first number, then take away the second number. Alright, now you can use your calculator to do all this, but you must show your working, so you must show some sort of numbers like this, all written out 3 cubed or 3 squared and so on. That gives me 36 minus 12, which is then fairly straightforward. 24, that type of page has been on every exam, the part A and the part B bit. Right, next question, number 13. Find the x-coordinate and the nature of stationary points. Now for nature, that means do dy dx squared we've already seen. Now I would tell my pupils for stationary points dy dx equals 0. Lots of people just dive in straight with dy dx. Stationary points means when we're at the top of the roller coaster or the bottom of the roller coaster really, and so you're flat to the ground. Your gradient is 0. So the first thing I've written down is dy dx equals, because I've differentiated. It didn't look very nice with the over 3, but actually over 3 makes life a little bit easier for us. The divide by 3, because these 3's will simplify out. The 14 over 2 will simplify out. And remember the differential of 10x is 10, not 0. Now that gives me that line there. Okay, so the next thing I've said for stationary points equals 0. I don't need to write that on, but it's good practice to get used to writing it. So for stationary points dy dx equals 0. Now next thing, this one does factorise. I think on every additional maths paper I've ever done for stationary points I've factorised. I think on every A-level paper I've ever done, but don't quote me on that because I might have made an error, but nearly every paper. So what I'm telling you is here, if you can't find these to factorise, I would go back and check if you've made a mistake. Okay, so I've rushed through this bit because this is B grade GCSE maths, factorising those, find the values, find the x coordinate. Now often they ask you for the y coordinate, but this one just says the x coordinate. You wouldn't have been penalised if you did the y, but in case you're wondering why I didn't do the y. So that gets me 4 of the 7 marks, and then they're going to look for the determining the nature. Now that means are they a maximum point or a minimum point? So to determine the nature, you do d2y dx squared, which is the same as question 10. Same idea. Differential of 10, remember, disappears. And then you substitute in your x values. So I'm showing you here, when I substitute x equals 2, I get a negative answer. Negative answers, anything less than 0, means they're a maximum. When I subbed in 5, I got 3, which is greater than 0. That means they're a minimum. So please make sure you learn how to decide if they're a maximum or a minimum. Generally at an A level, they often ask you to draw the graph, which does help explain that topic even more, why it's maximum and minimum. But for additional maths, we're just pushing you along the way to get to understand about maximum and minimums on the curve. That question has again been on every single additional maths paper I've ever done. Obviously the numbers change each time, but you will be seeing loads like that. Next page, question 14. Now the problem is with differentiation first principles, there are so many different methods for teaching this question out there. I've stuck to the one that I was taught when I was in school. So I'm sorry, lots of you will do a different way, and I would advise you to stick to the way you are shown in school or your centre. And there are different ways. This one isn't actually on mark scheme, but it is acceptable. I've checked with people at the WJC, and this is acceptable the way I do it. So this is the way I show my classes. I don't do delta X, I use H. Several schools will use delta X. There's so many different ways, as I say. So if you've done a method like this, I've seen lots of people I've marked for have done these sorts of methods. This is one of the ones. So that first slide, wherever I see an H, I replace with X plus H. The types of things I'm used to seeing when I mark these for my students are, they don't write the limit H tends to 0, and often I see them write the limit H tends to 0 before the equal sign. That's in different methods, not just in this method. Okay. Then my next line, I've expanded the brackets, I've folded out basically and multiplied it out to get to this stage. Don't forget the minus idea here, that the minus times a minus. And again, no matter which method you do, you're going to do some of these things similar to me. And what you'll find is anything on the back, anything on the f of x bit would disappear. You would simplify out with anything you've done in your expanded brackets. If you don't take away anything, your extra terms, your original terms, you've definitely done it wrong. So first of all, I did f of x plus h minus f of x. So I've crossed it out. Then my next line, I've just tidied up to make it simpler to see what's going on. And the next bit here, you will notice all the terms on the top have an h in them. If they don't have an h in them, you will have gone wrong. You will have made a mistake somewhere along the line. So my next line basically divides everything on the top and everything on the bottom by h. Now again, it's still always the limit h tends to 0. Now some people might well put in 0. I wouldn't be putting in 0. H tends to 0. We're going to assume it's 0, but I wouldn't write plus 0. So I've almost got to the final line. Here's the final line. Now I stress this is the way I teach it. There are many different methods. Next one, question 15, graphs. Now you will do things like this in GCSE, higher tier maths. You'll also do things like this in A level. I find the additional maths one is a slightly different method. But it is a calculator paper. This has been drawn really nicely for you. They've given you the numbers 0 and 90. So all you do is press sine of 0, then sine of 180, because it's 2 lots of 90, then sine of 360, sine 540. And you will end up getting some crosses that look like where mine have been. And I've drawn them up, joined them up without a ruler. Now, mine certainly is the best drawing. The top should go as low, should go up as high as the bottom goes as low, but it doesn't look like that. But I would get the mark. I haven't done the labelling in the right place, really. I should have put the minus 1 up. They're not too worried about that. They're looking about that you understand the idea. I always tell my classes a sine curve looks a bit like an S. It sort of looks like an S. Now, why have I drawn this extra line on? Now, the reason why I've drawn this extra line is they want me to find out sine 2x at 0.47. So by here, that is 0.47. That line is at 0.47. And this gives me values of 14 and 76. Now, I say I would teach A level differently, but for additional maths, often they ask you to draw graphs of sine 2x, sine 3x. And then that's why I've used this method. So you'll be shown something slightly different for A level. But for additional, draw the graph and then use it, because they want sine 2x equals 0.47. This gives me an answer at 14 and at 76. Now again, where did I get that from? You should know this from a higher tier maths. It's symmetrical, so I've come in 14 from there, and I've come in 14 from here. Same, I've come in 14 from here and 14 in from here. So this gives me the 2x answers of 28. 152, 388 and 512, but they don't want the 2x answers, they want the x answers. So I halve all of those, leaving me with the answers of 14, 76, 194 and 256. Now again, it's another topic that you might be shown different ways in your centre. Next one, integration. This is on every year's exam, but there was a slight twist. The slight twist coming from where it says x is greater than 2. Now this says area, integration tells us the area between the curve and the values they use. Now this one says x is greater than or equal to 2. So if I show you my next picture, this is why I've drawn this line on x equals 2. So actually you only want the area between the curve, between the limits of 2 and 6. Now to do the area, I integrate. Several people probably would have used the limits of 6 and -1, which will be costing them a couple of points. This gives them the answer integration as earlier, increase the power divided by the new power, and again with the limits of 6 and 2. Just to remind you, why did I say limit of 2? Because the question said x is greater than or equal to 2. Now I've substituted those numbers in again, substituting in 6 first, showing my working, not showing 6 cubed, but showing what I did when I pressed those in. And this leaves me with the answer of 104/3. Now you could have written that as 34.67. Do not write as 34.6. 34.6 recurring is a better answer, but generally you're better off leaving your answers as fractions. Now the final question for this paper again is one that's on every year. So any ones I say are on every year are really the key ones to practice, because you're going to see a lot of these. So find the equation of tangent. Now what I tell my class is if they ever need an equation, that means they need a gradient and a point. To do a gradient of a curve, you've got to differentiate. But first of all, we haven't got the full point. We've only got x equals 1. So I'm going to find the y value by substituting x equals 1 into the y equation. When I substitute x equals 1 in here, it's giving me the answer of -1. That's giving me 1 point. As I say, I've got a coordinate, now I've got a point, and now I need a gradient. And I do that by doing dy dx. I've substituted in x equals 1 because it says x equals 1. That gave me the gradient of 2. So I now have a gradient of 2. And I have the point. Now there's different ways of laying out your equations. I use this method. Lots of centres will use y minus y1 equals m open brackets x minus x1. It's all the same, it just rearranges. So I use this one because it tells me that the gradient is worth 2, y is worth y because it wants it in the format of this, y1 must be worth -1, what we worked out here, x is x, and x1 is number 1 because that's what we gave. So I've shown myself substituting that in, it gives me this. Just be careful, 2 times x minus 1 is 2x minus 2. As I said, if you do m open brackets x minus x1, it would drive you straight into this line. But the question does say it's got to be in the format, and additional mass, it does have to be in the format. So ax plus by plus c. So my final line, and you'll notice I've added a little correction because I made an error, is 2x minus y. Now it might say it needs to be in the format ax plus by plus c, but if they're minus signs, you leave them as minuses. Now originally I would have lost a mark for accuracy for not putting equals 0 on the end. Now that's the second half of that paper done. Good luck. As I say, if you need to look any extra videos, you can look further on my previous 10 slides. We'll go through the more common topics.